All right. So we're in the middle of worksheet 7, the bottom of side A. Is that where we're at, guys? Okay. On number 6, this -3, the 0 at -3 had a multiplicity of 2. That means if I wrote it out, it would look like this. There's really 3 zeros. Do you understand that? But so it matches the degree. But this one is repeated, which means it does what on the graph? Okay, so at -3 there is a bounce, and at 1 there is a cross. It's crossing, it has an x-intercept. But what degree was this? If I multiply that, I have an x times an x squared. It's positive leading coefficient, so where's the left side? It's down. So it's coming from down here. What does it do at -3? Bounces and then comes back up through 1 somehow. I don't care about any other accuracy other than the shape and the zeros. All right, what's different on number 7? This is a really easy one. What's going on? Degree 4, there's just an x to the 4th. The zeros are at, okay. Any bouncing? Where do I start on the left, though? Up or down, though? What's the end behavior? It's positive, so both ends are up. So it's just a W. And we need the big dot theorem over here, apparently. All right, this one gets more complicated. Out front, there is a -3x to the 4th. If I set that equal to 0, it means there is a 0 at 0 of multiplicity 4. Everybody okay?
Yes.
All right, where else are there zeros? There's a 0 at 5 of multiplicity 2. And there's a 0 at -1. The leading term test says I can ignore all the constant stuff up here and just look, it says I have a -3x to the 4th. If I FOILed this out, I'd get an x squared. And back here, I'd have an x. So my leading term would be -3x to the 7th. So what shape is that? Where's the left side? Far left. Okay, so the shape is this way because it's negative with odd degree. All right, let me put these on here real fast. I have a -1, a 0, and a +5. So you told me to come from the top on the left. What do I do at -1? Cross. Then at 0, I go bounce. And at 5, also bounce because both of these are even multiplicity. That's supposed to be at 0. I didn't draw it very well. Did it end up going the right way? It ended up going back down, right? Which it should be because it's odd. Everybody's okay? There are lots of checks and balances here to help us make sure we're doing these right. I have one more quick example because the one on the quiz I think might look more like this. It has a -x out front. This term is squared, so what would a -1x when you square it become? Okay, and back here there's a 2x that's cubed, which would become 8x cubed. So the actual leading coefficient would be a -8, and I'd have an x to the 6th. So what shape is this one? Both down. Okay, so it might be doing something in here, but it's got both ends down. Now, where are the zeros? This x out here means there's one at 0 of multiplicity 1, right? No squared on that. What's going on here? Be careful. It's +3. Everybody gonna get that right? Because 3 minus 3 would be 0, right? So that one's +3 multiplicity 2. And this one is a 5/2 multiplicity 3. Okay, where does it bounce? Anywhere? Here. Does it bounce at the 0? Does it bounce at the 5/2? No. Okay, if you graphed this, it crosses at 0, it crosses at 2.5 or 5/2, and then closely thereafter it crosses again at 3. It's both ends down, so it would cross. Now, at 5/2 it's a multiplicity 3. Honestly, if you got close enough and looked, it would have this little like cubic shape to it right there, but it doesn't matter. As long as you cross, I'm good. Because then it's got to come back and do what at 3? Bounce. Okay. So I made that look all funky, but I don't really care. All right. Number 9 on the back. I already did this problem, so I didn't want to spend a ton of time on it. This is a degree 5 polynomial. Why does this graph stink if it's degree 5? Why is this a really bad window? Not the right end behavior. It should be coming back up over here somewhere, right? So I just wrote, it says describe why this is not a good window. And I said it's a degree 5. So, this is supposed to say so. It's incorrect end behavior. You don't have to write all that. Just write. It's degree 5, bad end behavior. Not, all the end behavior is not there. Whatever you want to write. What's wrong with this guy over here? Why is this a really bad for this equation? The end behavior's right now. Yeah, can you tell what's going on in here? No, I can't tell where the zeros are at all, right? Now, on this particular function, you may have to use 2 different windows to be able to see both the end behavior and this, the zeros. But, all right. So it's a great question, but it's not on the quiz. All right, which of these seem okay? Which ones don't seem like they would match that graph?
Well,
B you think is okay? What's wrong with C? This would have a negative x to the 4th, which is like a downward W, right?
so it's no good.
Actually, so would D and so would E, right?
No good.
These are all this shape, so these don't work. What about A or B?
Not A.
This one has a 0 at 0, -2, and +2. Does that work? Except when you take a negative x times an x times a negative x, you would get a positive x cubed. Is that what the shape is? Okay. So does this work? 0, -2, and 2, and you get a negative x cubed? That seems better. Tell me what's wrong with this. Good. This would have to have a bounce at -2 and no 0 at +2, right? Nope. It would bounce at -2 and then cross at 0. Okay? It'd be the same shape, but not the same graph. All right. This is an easy question. What is the multiplicity of the 0 at 2 in this equation? Okay, this is the 0 at 2, and its multiplicity is 2. What if it had said -2? Then the multiplicity would be 3. If it said -3, the multiplicity would be 7. Okay. I heard that the PSAT had one of these questions yesterday, a box with the corners cut out. I'm so excited.
I'm so
Okay. I'm going to go quickly through this because it's not on the quiz. There may be one on the test. There's probably going to be one on the test at the end of this chapter, but we'll practice it again before then, okay? I'm more concerned with what's on the quiz tomorrow, but I'm going to do it quickly. If you had a 60 by 15 piece of cardboard and you cut little X-shaped X by X squares out of the corners right here. Get rid of this corner, this corner, this corner, this corner. They're all X by X. So what used to be 60, we went in X from each corner, so this dimension is now 60 minus 2X. So the long way on the box is 60 minus 2X. Sorry, I wrote that really badly. This little short dimension used to be 15, but we went in X from each corner, subtracted an X, cut it off. So this way it's 15 minus 2X. Now what is the height of our box? Yeah, it's just whatever that X is. So volume, you just take all three of those dimensions and you multiply, yes? Length times width times height. So for A, the expression would be X times 60 minus 2X times 15 minus 2X. Part B says, when is it making a volume of at least 450? I will not ask an at least question on the test. I'll just ask, when is it exactly 450, okay? They'll have one answer. But for today, it says, when is it at least 450? X is the value we cut in from either way. So right here, if I can't have a negative dimension, I could go, if it was 60 across, I could go 30 either way. Does that make sense? But the other direction was, other side was only 15. Can I go in that far? How far can I go in from each side if it's only 15 across? And I'm going the same way from each side. I can only go 7.5. Everybody see what I'm talking about? I can't have X values greater than 8. So I set up my window. I did 0 to 10, but you could have done 0 to 8. All right, for the X. If we wanted to hit 450, I put in my Y sub 2, 450. Does that make sense? So it's going to draw a horizontal line. So my Y value had to go up above 450. I graphed it. My window wasn't really big enough to see the whole shape, but can you tell what's going on here? It's going up above 450, and then it's coming back down below 450, okay? So this intersection point to this intersection point, all the values in here have a volume of greater than 450. So I found those two intersection points, and I got these two crazy decimals. So you would say between 0.55 and 6.79. So you could have a really shallow box or a really deep narrow box, and you'd get the proper volume. The work is just to use your calculator. Now, there isn't going to be work besides writing the expression. All right, on a test, we'll practice more later. This you don't have. If you want to take pictures or write notes, you can, but this is a question off the quiz. How do you list all the possible rational zeros? Do you remember? The factors of the constant over the factors of the leading coefficient. So we have a 20 and a 3. What are the factors of 20? Factors of 3? Okay. So remember, you have to write out what that means, but you don't have to put a plus or minus in front of every single one to make me happy. So you got to put one big plus or minus. And what would this mean? If you put them over 1, you get...
1, 2, 4, 5, 10, 20.
Yep. Then you put them over 3, you get 1/3, 2/3, 4/3, 5/3, 10/3, and 20/3. Guess what? I'm not putting that one on the quiz tomorrow because I don't want to check that you have all those answers. But it was a good one to remember how to do it. Yeah, exactly.
I was delivering all kinds of stuff, so I might as well interpret class about the brats.
Yes.
I can easily get some, but I don't have it.
Okay.
You're just talking about the little prongy
Yes,
things, right?
yes.
I mean, I used to make spinners out of them with...
Yeah.
I just find it.
Sue found these. You just lay them on top of the thing and it'll be beautiful. Thank
Nice.
you.
Okay.
All right, guys. Maximum number of possible zeros. 4 turning points. 3. Easiest questions on the quiz, right? All right, now it says factored form. This one is not real nice because I just made it up. It's 16 and 5 to make 80 and add up to 21. It's not pretty, okay? Yes, x squared minus 16 factors further. X squared minus 5 does not, but it does have real zeros. What are the exact real zeros? 4, negative 4, and then x squared minus 5 equals 0 means x squared equals 5, x equals plus or minus the square root of 5. So we found all 4 zeros were real. Everybody good? Got down what you want, took a picture, whatever you wanted. Can I go on? All right, this is an easy one. You shouldn't need to graph it, but you have your calculator if you need to. A negative x to the 7th would be this shape, yes? So domain, quick. Range. Intercepts. Yeah, because it's just going to. Continuous. End behavior, left end, right end. Okay. Yeah. It's not a complicated one. Remember we spent some time the day we did power functions. We had to do a bunch of these. We're just asked these questions. So I put on the quiz. Easy peasy. All right. This is not the easy questions. It says find all the zeros of this 4th degree polynomial. Guys, it says this exactly on the quiz. Use the graph and division. Guess what you have to use? The graph and division. It's not a subtle hint, okay? So, I graphed it. All the factors of 42 are possible rational roots. But this is what the graph looked like. I found one worked at 3. I found a 0 at negative 2. Then I found the other 2 were crazy decimals. What does that mean? They're not rational. They're probably square roots. Okay? So what do you have to do? It said to use division. Okay, so the exact zeros were at 3 and negative 2, but then you have to do division. You can do long if you really want to.
I think you just put that no one should do long.
Wait, is that long division?
There is a long division question, yes. Okay. What do I do after? Yeah, I have a depressed polynomial, but I still have to do the negative 2. Okay. Now what's left? If I set that equal to 0, I get...
Plus or minus 7. Would you look at that?
Okay. It could be. Could very well be. The worst case scenario is you'd have to use quadratic formula when you got to the end here, right? Ugh. If it had been at the end like x squared plus 9 equals 0, you get negative 9. Are those real zeros? No. All right, I'm moving on. We okay? Yes, person. It doesn't matter. You can do them in either order. Great question. You could have done the negative 2 and then the 3. Yes. You have to do the question was, do you use the depressed polynomial? Yes, you have to do them consecutively. Otherwise, if you went back and started again, you'd end up with a degree 3 all over again, and you want to get it down to a degree 2 in the end so that you can use either quadratic or factoring or whatever. Okay. Guys, this is on there. I'm not going to spend 10 seconds on this. It says find f of c using synthetic division where c is 3. You could do synthetic division and the answer would be the remainder, but you could also just do what? put the 3 in all those places and find the answer, yes?
Yeah.
Okay, moving on. There is one of these, okay? But the directions, it says over here, the directions on the quiz tell you, use a quadratic, or use a cubic, or use a power, or whatever it says. So again, it's stat, enter, you put it in. You go stat y equals, turn your plot on, do a zoom 9. Then it does say on the quiz to draw a sketch of the graph like I've done down here. This particular example says use power. So it's stat, right arrow, and then you go down and you find this one. It's A. It says power regression. And then you get this. What is this down here telling me, guys? Can you tell what that's telling me to write on the blanks here? 5.464 times x to the b, which is 4.753. And then you just put in a 9, right? Everybody okay? I can come back to this if you need me to come back so that you can practice this. But we got a lot more to do. This one is probably the trickiest question for most students on there, but we just did it yesterday, so maybe you guys are better off because it's fresher in your mind. I don't know. It says there's a 0 at 5, comma, a 0 at 3, comma, a 0 at 1 minus 2i, which means there has to be 1 at 1 plus 2i. It says write the factored form with real coefficients to get full credit. If you write out x minus 5, x minus 3, x minus the quantity 1 minus 2i, and x minus the quantity 1 plus 2i, you'll get most of the points for this question. But these aren't real coefficients yet, so the only way to get all of the credit is to distribute that negative and then you have two choices. You can use the shortcut or the FOIL thing. I'm going to show you the FOIL one more time. You take this x and you distribute it all the way through here. So you get x squared minus 1x minus 2ix. Then you take the negative 1 and you distribute it all the way through here. So you get a negative 1x plus 1 plus 2i. Okay, I'm not worried about writing them up above each other. Then you go through with the 2i to all three of these. You get a plus 2ix minus 2i minus 4i squared. Okay, I promise if you did it right, you're not going to end up with an I anywhere because those are going to cancel. What is minus 4i squared the same as?
4.
Plus 4. So I have left an x squared minus 2x's and a plus, be careful, 4, and this one right here makes 5. Okay, and you need an x minus 5 and an x minus 3. Now do we have only real coefficients?
Yeah.
So you can stop. It doesn't have to be in standard form. Do you remember the shortcut?
Yes.
It is x squared minus the sum times x plus the product. So the two zeros are 1 minus 2i plus 1 plus 2i. When I add those together, the sum is 2 because the i's cancel out. If I do the product, 1 minus 2i times 1 plus 2i, 1 times 1 is 1. I get a positive 2i, a negative 2i, those cancel out, and I get a minus 4i squared. 1 minus 4i squared becomes 5. So then the sum was 2, the product was 5.
You literally just did the exact.
Yes.
So on the quiz, it say like x squared minus 2x plus 5 would you want that?
It won't factor because otherwise you wouldn't have imaginary zeros. That's okay. Yep. It can be as factors as it will be, it just can't have i's in it, okay? All right, I want to talk about worksheet 8 now. This is due for homework. I'm going to try to do one on each section. I got 8 minutes left. So I am doing problems right off tomorrow's homework check, okay?
Unless I gotta do the happier I am. I am lazy.
Okay. Problem number 2. The directions for all of the front side say state all the possible rational zeros. So for this question, I would just need the factors of 33 over 1, which are just 1, 3, 11, and 33. I'm halfway done with the problem. This is number 2. The factors are 1, 3, 11, and 33. I'm doing number 2. Then it says find all the rational zeros. So all I have to do is check which ones of these work. That's all I have to do, because there can't be any other ones. I graphed it. I tried 1. It came up -12. I tried -3. It came up 0. And the other ones didn't seem to be working, so I went ahead and found them. Are they rational? No. So the only rational zero for this problem is at -3, and you're done. You don't have to do all this stuff I did over here. I was trying to prove to myself that it wasn't rational, the other zeros. So I did this, and I got a quadratic, and I did quadratic formula. You don't have to do that. It just says find the rational zero. We found it. It was at -3, okay? All right, on 3 and 4, it says find all zeros. That means even if they're irrational. So for question number 4, the factors of what over what? 9 over 5 give me 1, 3, 9, 1/5, 3/5, and 9/5. I graphed it. Notice that's the second step to all of these, okay? I graphed it and I found a rational zero, a nice one. Out of all of those numbers, the only one that worked was when I typed 3 divided by 5, trace 3 divided by 5, enter, which is 0.6. That's the only one that worked. The other 2 are irrational, so what do I have to do to find them? No crying in pre-calc.
Oh, lots of crying.
Apparently this is a league of their own.
Divide! Okay,
Whoa.
we're going to divide. We're going to do 3/5 or 0.6. It doesn't matter. 5, -3, -15, 9. This is not as bad as it looks, guys. It's not as bad as it looks. 3/5 times 5. Added is 0. 0 times 3/5 is 0. -15 times 3/5. Last one you got to do, guess what it should be? -9, so that it comes out 0. Okay. We are left with, what's this depressed polynomial mean?
5x squared minus.
Okay. If I solve that, I move the 15 over, divide by 5, I get 3. So the other 2 are at?
Plus or minus square root of 3.
Okay, so all of the zeros were 3/5, square root of 3, and negative square root of 3. Guys, but I don't want decimals, okay? It should say find all the exact zeros. Worst case scenario, you might have to do quadratic. Yes. No, I graphed it to find that it had a 0 at 0.6 or 3/5. Yes.
Okay, on the calculators, like, if you get like a irrational decimal number, I know you have to figure out, is there a way to reverse it and get the root?
No. Some people will write down all the decimals, go back to the home screen, and square it to see if it comes out halfway nice.
Oh, that's a good idea.
Okay. I'm teaching you why you don't need to do that. Okay. This time it says do the same thing except write the factored form at the end. This is a really nice one, guys, number 6, because when I factored it, when I found all the zeros on the calculator, by the way, you're supposed to write the factors of 1 over the factors of 4. So you actually get 1, 1/4, and 1/2 for this one. But then I graphed it, and I found negative 0.5 worked, negative 1 worked, and positive 0.5 worked. Is that all the zeros? Okay. There's a reason everybody would still get this wrong, though, because if I write x plus 0.5, x plus 1, and x minus 0.5, is it going to FOIL back to this?
Yeah, probably not.
Because it's not going to have a 4 anywhere. So all you need to do is put the 4 out in front, or how else could I write x plus 1/2 as a factor? You could write 4x plus 2. Most of us would think this would give us a fraction of negative 1/2. This would give us a 0 at 1/2, and then it had an x plus 1. This is the pretty way to factor that, but I don't care. It's equivalent. If you get decimals, just write the leading coefficient out here and I'll be good. Okay, on the back are the ones where you have to square both sides, okay? I had written down that I should do 4, 6, 7 with you. I'm going to do 6. Okay, this is icky. You got to do it twice because of this too. I don't know. I hope I have enough time to do this one. Okay, on the left side, you're just going to square. On the right side, when you square it, you have to FOIL it out. Okay. This just gives you 1 minus r. Over here, 2 times 2 is 4. 2 times this would be negative 2 square roots of garbage. Inside 2 terms gives us another negative 2 square roots of garbage. That's supposed to say square root of 3r plus 1. And then this garbage times this garbage. Well, yes, it's squared, so we just get 3r plus 1. The parentheses don't matter. Okay. So over here I have 1 minus r equals 4 minus 4 blah blah blahs plus a 3r plus 1. What can I do?
You can subtract 5.
If I subtract this 1 and this 4, so a total of 5, I'd get negative 4. If I subtract this 3r, I have a negative 4r equals negative 4 square roots of 3r plus 1. This sounds like a really good time to do what?
Correct.
Divide everything by negative 4. So I get 1 plus r equals the square root of 3r plus 1.
Divide.
Now I have to, once again, square both sides. The left side will be 1 plus 2r plus r squared. The right side is 3r plus 1. I have r squared minus r equals 0. So I get r equals 0 or 1. You should test them both, but by my recollection, they both work.
Sweet beans.
I get square root of 1 equals 2 minus square root of 1. Or I get square root of 0 equals 2 minus square root of 4. Oh, that one doesn't work, does it? I don't think 1 works.
No. 1,
Because I get 2 minus 2 is 0. Yes, I do. Yes, it does. I'm just brain dead. They both check. They both work.
I'm always